Number 8 says determine the transformation. So this would be stretch of 2, right 2, down 1. Okay, fill in the blanks. Yep, that's all that one says. It says, are these inverses of each other? So first, before I answer this how they want me to, I'm going to do it the cheating way. I'm going to switch x and y and then solve for y. So it'd be x equals log base 5 of y plus 7. So the first thing we're going to do is base 5 both sides. 5 to the x, and then equals y plus 7. Then we're going to minus 7. 5 to the x, and then the minus 7 is out here, equals y. Is that the inverse? If you look at this, the question is, and again, it's really small, is that minus 7 like this? Or is it like this? Because that's very different. We know the inverse is this one. To me, it appears that the minus 7 is up with the x, so they probably shouldn't be inverses if I do it. I mean, they won't be inverses. So if I plug them into each other, then it shouldn't cancel out. So let's see if I plug this in right here. So this would be log base 5, and that would be 5 to the x minus 7 and then plus 7. Now, here's why this one is not working. So the algebra is not working here. We can only cancel out log base 5 and base 5 if there's nothing added, multiplied, subtracted, or divided to that base 5. This is kind of like blocking the cancellation. So it actually doesn't end up canceling out. And if it doesn't cancel out, can you add an exponent to something that's not in an exponent? No. So this is not canceling out to be x. So again, the most important thing is that you get the yes or no right. So if you're ever like, oh, I don't know if these are inverses, do it the cheating way first. Just switch x and y and then solve for y. Because again, the most important thing is the yes or no answer. All right, this says solve the exponential equation for x. So when you see this, you'd say, okay, there's only one x in the exponent, so we need to isolate the base. So our first step is add 19. 17 e to the x equals 19 plus 15. 19 plus 15, which is 34. Then we'll divide by 17. So e to the x equals 34 divided by 17, which is 2. Then to undo base e, I'm going to ln both sides. So x is no longer in the exponent, it drops down. So we have x equals ln of 2. So we have the we have the logarithm answer, and the decimal answer we find by plugging it into our calculator. So ln of 2 plugs into our calculator and gives us 0.69. It's much longer. I'm going to just round to 2 decimal places. It says 4 decimal places, so 0.6931. Evaluate the logarithm. These ones are all so easy. I shouldn't do more than like 2 of them because you just plug them into your calculator. Log of 11 is 1.041392685. Then let's go do ln of 8. Again, you can just type those into your calculator. 2.0794. So none of those should really take, too much brain power because log is in the calculator programmed in, and so is ln. So those are all easy. Expand the logarithm. So when you multiply, you add. So we would say this is log base 4 of 4 plus, when you multiply, you add, log base 4 of c. Now again, anytime you do this and then something simplifies, they want you to simplify it. Log base 4 of base 4 is 1. So our answer would be 1 plus log base 4 of c. When you multiply, you add. Make sure you only split apart multiplication and division. There's no division, so we wouldn't split apart anything with that. So remember, when you multiply, you split apart with addition, and when you divide, you split apart with subtraction. You're not allowed to actually split apart any addition or subtraction signs. So this is stuck together. This b minus 3 is actually stuck together. It can't be split apart. So you would say log base 4 of x, then a plus sign because of the times sign. Log base 4 of b minus 3. This would be log base 4 of base 4, then a times sign, so I do addition. Log base 4 of x, then a times sign, so I do addition. Log base 4 of c minus 2. Again, you're not allowed to split apart subtraction or addition signs. You're only allowed to split apart multiplication signs, which is what we did, and division signs, which there wasn't any division signs. When you split apart division, it's subtraction. It says, okay, here is a log. It has been transformed. What is the transformation? Well, the only transformation is stretch of 2. We know stretch and compressions go to the y values. We times them by 2. So it says what happens to the point 1, 0. You'd say x stays x. I'm going to times my y value by 2. So it's still 1, 0. Since 0 times 2 is 0. What happens to the point 2, 1? So again, you'd say 2 stays 2. Then I'm doing 1 times 2 since I'm timesing my y value by 2. So I'd get 2, 2. And then you'd say all logarithms, unless they're shifted left and right, have vertical asymptotes at 0. So I'm going to draw in my vertical asymptote at 0. And then I would start with, okay, well, we have some points. Let's just use those points. Let's make our life easier. Over 1 up 0, over 2 up 2. And we know logarithms have this shape. It's a sideways exponential on their side. The function is reflected across the y-axis. We know we times our x's by -1. So what happens to this point? You'd say, okay, the only thing that's happening is reflect across the y-axis. We times our x values by -1. So this would be -16, 4. All right, this says expand the logarithm. So you would say when you multiply, you add. When you divide, you subtract. Any exponents get pulled in front as multiplication. So this would be log base 7 of 2 plus sign 3 log base 7 of t. The 3 is because this exponent 3 gets pulled in front. Then minus log base 7 of y. Again, exponents get pulled in front. So we'll have 7 log base 8 of z minus, since it's on bottom, it's minus, anything on bottom gets minus 6 log base 8 of t. This would be log base 4 of 16. Then it's a time sign, so plus 6 log base 4 of y. Why did I put the 6 in front? That's what we do with exponents. Then a minus sign because these are on bottom. Log base 4 of 7. Then it's still, even though it's a time sign, because it's on bottom, it gets a subtraction sign. That's a common mistake of students is they'll say, oh, multiplication, so I do addition. Nope, on bottom, that's wrong. On bottom, you do subtraction. Minus 7 log base 4 of t. Again, I pulled the 7 in front. And then this is a log base 4 of 16 is just a number. If it's a decimal, they'll have you leave it. If it's a whole number, they want you to calculate it. To calculate it, I'm going to do the change of base formula. Log of 16 over log of 4, which is 2. So that'd be 2 plus, I don't want to rewrite the rest of this stuff. Write the equation if it is shifted right 3 units. So you would say, okay, log base 3 of x minus 3. It's just left and right are grouped in with x. We put opposite of the sign. And so we'll say f of x equals log base 3 of x minus 3. Solve the equation for x. So you'd say, okay, there's many ways to do this. I'm going to probably just log base 3 both sides. So then we have x equals log base 3 of 17, which then you need to calculate by doing the change of base formula. We know that that's rewritable as log of 17, we learned this, divided by log of 3. And then you'll just put it in your calculator. The change of base formula allows us to write it with log or ln so that we can put it in our calculator. So log of 17 divided by log of 3 is 2.5789. It said 4 decimal places, so there we go. Determine the inverse. So I would switch x and y and then solve for y. So I'd base 2 both sides. 2 to the x equals y. That's my inverse. So really easy. Again, determine the inverse. So we'd switch x and y and then solve for y. So the first step would be to base 4 both sides. 4 to the x. Those cancel out. Log base 4 and base 4 cancel out equals y minus 1. Then we're going to add 1. So we have 4 to the x plus 1 equals y. And now that y is alone, that's my inverse. Write the equation in a logarithmic form. Leave your answers in logarithmic form. So Since they want us to solve by logs, I guess, which is silly. There's a lot easier way to solve this. Because look, since these are both base 3, we could just solve using the exponent rule. If they're the same base, we can just set x minus 2 equal to 1, then add 2. X equals 3. That's way easier than solving by logarithms. So I'm going to ignore the instructions, and I'm going to solve by easiest method. 6 to the x plus 5 equals 1. We could go ahead and solve by logarithms here if you want. So we would log base 6 both sides. These cancel out. So we have x plus 5 equals log base 6 of 1, which then we would need to type into our calculator. So let's rewrite it. That's log of 1 divided by log of 6, which then I put in my calculator and see if it's a whole number or decimal. If it's a decimal, I'll leave it probably. And then if it's a whole number, I'll write it down. Log of 1 divided by log of 6 is 0. So x plus 5 equals 0. So subtract 5. X equals negative 5. Again, I'm going to solve this one the easy way. If we have 5 to the x plus 4 equals 5, it's really 5 to the first. Because these are the same base, I'll just solve using the exponents. X plus 4 equals 1. Subtract 4. X equals negative 3. All right, we would use the change of base formula. So we would type log of 1296 divided by log of 6 into our calculator. 1296 divided by log of 6, which calculates to be 4. We would calculate log of 8 divided by log of 2 in our calculator, which is 3. We already know this cancels out to be a 1, so there we go with that. Solve the following equation using properties, I was just looking for a minute, properties of logs. So before you can undo an ln, you have to have only one ln on the left and only one ln on the right. There's only one ln on the right, but on the left there's 2, but we can put them together. When you add, you multiply. And now from here, I would say to undo ln, I base e both sides. So I have x times x minus 3 equals 8x. A lot of kids will get here and get stuck. It's like, okay, what are we dealing with here? Well, technically, we need to distribute. When we're solving by hand, we have to get it set equal to 0. X squared minus 3x equals 8x. First step is always solve by getting it set equal to 0 when solving by hand. So we have x squared minus 8, 9, 10, 11x equals 0, and then we solve by factoring. So we pull out an x, left is x minus 11. Then we have x equals 0, x minus 11 equals 0, x equals 0, add 11, x equals 11. Whenever we're solving a logarithm, we then plug in our answers and make sure in the original problem it doesn't create a 0 inside a logarithm or a negative. If I plug in 0, it creates a 0 and a negative, which means I need to toss that solution out. If I plug 11 in, it doesn't create a 0 inside the log or a negative, so I keep this solution. It says it's reflected across, this log is reflected across the x-axis. What happens at this point? We times our y's by negative 1. So you would say 8 stays 8, but 3 will become negative 3. When it says evaluate, that just means calculate. Again, you could just use the change of base formula. So you'd say log of 181 divided by log of 3, and then put it in your calculator. Anytime you're calculating a logarithm, let's just make our life easy. And you do the change of base formula, then we don't have to overcomplicate it. Calculates to be negative 4. So we would type in log of 1 over 512 divided by log of 8. We would put it in our calculator. Again, the change of base formula. If you're going to do the change of base formula, just make sure you put the base on bottom. It's negative 3. So this will be log of 1/6 divided by log of 6. Log of 1/6 divided by log of 6. Just put it in your calculator and it gives you negative 1.